Hi, geometry students. This is Miss Kaiser. Again, we're starting a new chapter, and we all miss you. Since we're all distance from each other, the geometry teachers can't do the videos all together. So I'll be doing 3 of the videos. Miss Mick will be doing 2 of the videos, and Miss Moch will be doing 3 of the videos. So I'm starting with 11.1, circumferences and arc lengths. So the circumference of a circle is the distance around the circle. And I think most of us know how to find the circumference of a circle. It's either the diameter times pi or 2 pi times the radius, because the diameter equals 2 times the radius, as you can see down here. Okay. So that is the circumference of a circle, and pi is roughly 3.14159. So pi is a number, but the exact value for pi is pi. The decimal estimation is 3.14. Okay? All right. So as you can see here, the circumference of a circle, this is just going back over what the circumference of a circle is. So if we are to find the circumference of a circle with radius 11, why don't you see if you can do that using the formula? Now, I want you to notice that on big ideas, if they ask you for the exact value, they would want you to plug in 22 pi. If you plugged in the decimal estimation, which is this, and how I got that was I took my calculator and I multiplied 22 times pi on my calculator, or the decimal estimation for pi, which is 3.14. So I want you to know that it'll mark you wrong if you say 69.12. It'll say that that's wrong. But if you say 22 pi, it'll say that it's correct. So you have to read very carefully how they want you to answer the question. So if they said to 2 decimal places, then they want 69.12 inches. If they said exact value, then they want 22 pi. So some of you guys were emailing me about things in chapter 10 about, I put this answer in, but it marked me wrong because it asked for exact value. Exact value never has a decimal, ever has a decimal. So it is an exact answer, unrounded. That's why you have to use the symbol pi in the exact value answer. So why don't you take a moment to find the circumference of a circle with radius 4 millimeters. Okay, well, hopefully you got, oh no, this problem does not say radius 4 millimeters. Sorry, guys. It said it's got the circumference of 4 millimeters, and I want to know the radius. So we set circumference equal to 4, and that equals 2 pi r, and then you divide by 2 pi r. So your exact value, it always wants you to reduce. Exact value is always reduced. So don't say 4 over 2 pi, but say 2 over pi. And that is your exact value. And then that would be the decimal to the nearest hundredth. 2 decimal estimation is 0.64 millimeters. All right, moving on to arc length. An arc length is a portion of the circumference of the circle. You can use the measure of the arc in degrees to find the length in linear units. So what you would do to find arc length is to notice that if you have it in degrees, it's going to be theta over 360 times your circumference. And this is a way to simplify that expression if you would like. You notice that 2 goes into 360, so it's 180. Or you can just take theta over 360, simplify that fraction, and multiply it by the circumference. So when we take a look at finding the length of PR, now understand the length of PR is not the measure of PR. We learned that the measure of PR in the last chapter is 100 degrees. But now I want to find the length. So that's in inches. So what you want to do is take 100 over 360 and multiply it by the circumference, which is 2 pi times 12. So now your answer is inches, no longer degrees. So I tend to reduce the fraction of 100 over 360 as 5 over 18. Then I find the circumference, which is 24 pi, and then I multiply that out and reduce. So you can notice I reduced 24 over 18 and then multiplied that by 5. That's the exact value answer. Okay. And that would be the decimal answer. So to do the next problem, you would take 130 over 360 times 2 pi times 6.5. And then again, I found the circumference. I reduced my fraction. And then I did the arithmetic. That's my exact value answer. And if I wanted to 2 decimal places, I would get to 2 decimal places. So now the last one said, I want to know what the measure of angle JHK is. And I am given the arc length. So now I have that the arc length is 21. I don't have the theta. So it's theta over 360 times 14.32, which is our radius, times 2 pi. So I'm going to do a little bit of simplifying here. So I am going to multiply out 2 pi times 14.32 and get 28.64 pi times theta over 360 equals 21. Next, I cross multiply. So 360 times 21 is 7,560. And then I divided out my 28.64 pi. And in this one, I didn't get an exact value answer, so I took my calculator and I made sure I did 7560 divided by, and then in parentheses, and it must be in parentheses, 28.64 pi. That must be in parentheses. And that's the degree I got, to the nearest hundredth of a degree. Okay, a real world application problem. The radius of a wheel on a toy truck is 4 inches. To the nearest foot, how far does the wheel travel when it makes 7 revolutions? So 7 times around. So that would be how many circumferences? So first we're going to find one single circumference, which is 2 pi times 4, which is 8 pi. But then you're going 7 times around. So you must multiply by 7. So you get 56 pi inches that they've traveled. And so there is the 3 decimal approximation. So I'm going to write the approximation symbol here because it's approximately, not a very good approximation symbol. That is how many inches that wheel has traveled. Okay? So just remember, exact value, pi's in your answer. A decimal approximation, you would take your calculator, find the pi button, and multiply it out. Don't forget to reduce things as much as possible. Then the problem, forgot to say this, that's how many inches. But the problem, if you notice, says to the nearest foot. And you got to be careful because if Big Ideas ask for it to the nearest foot, then your 175.929 inches wouldn't be correct. We would have to divide it by 12 to convert inches to feet because there are 12 inches in a foot. That's how many feet. And then they ask you to round it to the nearest foot. So when you round it to the nearest foot, that means an integer with no decimal place. Okay, so it's 15 feet roughly. Okay, moving on here. A path is built around 4 congruent circular fields. The radius of each field is 100 feet. How long is the path round to the nearest hundredth of a foot? So, if you notice that each curve is 1/4 of the circumference, but how many curves are there? Yep, there are 4 curves. So that means that the circumference of one circle gives me these curves here. And then this length right here is 2 radiuses, which is 1 diameter, and there's 4 of them. So let's work this out. So if you've got 90 over 360, which is 1/4, then you've got 50 pi. But again, there's 4 of them. So I kind of didn't really need to do the 1/4. So here I've got 4 times 50 pi plus 4 of the 200 lengths all the way around. Now be very, very careful. For exact value, you cannot add the 200 and the 800. The reason why is it's 200 pi. They are not like terms. It's 200 times pi plus 800. You would be breaking order of operations if you added. So that's your exact value. Then you can take your calculator and multiply 200 times pi and then add your 800 feet. And that is to the nearest hundredth of a foot. I believe that would be 0.20. And that is to the nearest foot. So that one's exact value. Okay, and if there's any questions on this, we'll do Zoom sessions to see if you have any questions, and I can go over this again with you because it's a little bit more of a challenging problem. Okay. Measuring angles in radians. Recall that the measure of an arc is equal to the measure of a central angle. If there is 180 degrees in a straight line, then a semicircle's arc is 180. Suppose now you want to find the measure of not just a segment of the circle, but the entire thing. Since there are 360 degrees in a circle, you can say the circumference of the circle's measure is 360. So that means that the angle all the way around the circle, it doesn't mean that that's what the length is. Degrees are one way to measure a full turn around a circle, but the degree measures itself in an arbitrary value. Angles can be measured using radian measures. A radian measure is measured an angle by the length of the arc associated with it using the radius of the circle as a unit measure. An angle of 1 radian has an associated arc length of the radius. Converting between radians and degrees. So this is just an extra unit here. You are not going to be tested on this. But as you move to Algebra 2 or Algebra 2 Advanced, this will be useful knowledge. So we just introduced it to you. So the conversion to convert degrees to radian is 2 pi over 360, which reduces to pi over 180. And the conversion for radians to degrees is 360 over 2 pi, which is 180 over pi when you reduce it. So if you have a radius of 1, and so over here, if you have a radius of 1, then your circumference is 2 pi, which is 6.3, roughly to 1 decimal place, or to 2 decimal places, it's 6.28. And that is what all the way around a circle is in radians. Instead of 360 degrees, it's 6.28 or 2 pi radians. And that's how we got these conversions. So 360 equals 2 pi radians. So 1 degree equals pi over 180 radians, which gives us the conversion of pi over 180. Now, I don't want you to get too confused on this because, again, we're not going to be testing on it. It's just a nice little extra unit. So to convert from degrees to radians, you multiply by pi over 180. And to convert from radians to degrees, you multiply by 180 over pi. And 180 over pi degrees is 1 radians. So this is just a conversion like feet to inches. 1 foot is 12 inches. 1 degree is pi over 180 radians. 1 radian is 180 over pi degrees. So this is converting back and forth. So if we're converting 30 degrees, and in radians we always leave pi in the answer if we can. So you would just reduce that fraction and you get pi over 6 radians. So 30 degrees equals pi over 6 radians. Then we're going from radians to degrees, so pi over 2. So now we want to multiply by 180 over pi. And you notice the pi crosses out and you can reduce 180 over 2 to 90 degrees. And C, we're going back to converting from degrees to radians. So you're going to multiply by pi over 180. And you reduce 150 over 180 to 5 over 6. So it's 5 pi over 6 because we leave pi in the answer. And then back to converting from radians to degrees. So we've got 3 pi over 4 times 180 over pi. The pi's cross out and you get 135 degrees. Okay, so Again, this converting between radians and degrees is just a little extra bonus. You are not going to be assessed on this. Okay, well, I hope you guys have a good week. The other thing I wanted to make sure that was clear was we are doing 1 or 2 sections a week. So this week it's 1 section. Next week it's 2 sections. The following week it's 1 section and a quiz and so on. So please pull up the spreadsheet that is up on School Loop. The link is in the email we sent you and also on School Loop. Have a great week. Miss you guys. And please come to office hours if you need any extra help. I will be emailing you out when I'm available to help you with any questions that you have. Have a great day.